Alright, hello guys, welcome back to Level 2 Games. And last week, not many people came, but there was a recording too. So last week we went over finite state machines and the simple way to design enemy AI for your games, for any games, and it was also in collaboration with Godot site. Yeah. If you guys didn't came last week, the recording is also available on Discord, so you can check it out. But after we know how we can make an AI, the next thing that you want to do is to make your AI actually be able to move around. And it was not detailed last week because in different game engines there are different ways that you would implement this, and because we were having the session with Godot, so I didn't go through that. But for this week, we are going to go through the different ways that actually, did I turn on the audio? Okay, yes. Okay, so for this week, we are going to go through the different ways that you can implement pathfinding, or so-called allow your AIs or entities, enemy entities, to move around in your map, to attack your players or whatsoever, so that it actually has some kind of movement that feels natural. So what is pathfinding? Pathfinding is the term in games that means that your bots move around and it has a way for it to calculate the shortest route to go from point A to point B on your map. And it allows it to move intelligently, such as you can program it to avoid obstacles. You can program it to find the most optimal path from one point to another. And you can also program it to follow the geometry of the terrain or the game stage that you have. So, actually, this is a very simple question because in all games, the easy way that we can kind of think about how we traverse the terrain and traverse the game stage is to model the entire thing as a graph. Okay, we can model the entire thing as a graph, where we subdivide the game stage into several different smaller areas, which can be seen as the nodes in the graph. And then we just need to make sure that these nodes connect directly to the nodes that are next to it and diagonal to it. So they are kind of interconnected to 8 different pieces next to it. And the very common graph traversal techniques, if you have taken 24DS or 24D, then you should know that we have DFS, BFS, Dijkstra's, Bellman-Ford, and Floyd-Warshall, which are different types of graph traversal techniques that are used in different scenarios. But as we know, we make games, so it should be fast, right? We need the fastest algorithm. Remember that our game needs to update 60 times, 120 times every second. If the algorithm is very slow, what will happen? Your CPU cannot handle that many calculations, and then your frame rate tanks because it cannot finish the update within that 0.1 second of time that you give it to. So what is the most efficient algorithm among these 5 algorithms that we have here? Any idea? Right, it's Dijkstra's algorithm. Yes, I heard the answer. So Dijkstra is the fastest graph traversal algorithm for single source shortest path. Theoretically, yes. It has a time complexity of v plus e log v. Do I need to explain why? Okay. I'm sure I don't. Okay, you can Google it. There's a lot of proof online. Right. So Dijkstra finds the shortest path from a single source to all nodes in the graph. And even if you terminate it early as it goes to the destination, it would also have to go through so many different nodes in the graph to get to the destination, which is slow. Okay, imagine all this redundant calculation that you do to all the nodes in the graph, and then you found out that I don't need to know what's the shortest path to go from point A to point Z because I just want to know how to go from point A to point B, right? So we don't need to calculate everything. And as I said, we need to update 60 times, 120 times per second. It's not ideal to have so many redundant calculations that are being processed. So you need a faster algorithm. And ideally one that does not traverse all the nodes. And one that allows us to go from just one point to the second point in the fastest way possible. So, introducing the A-star search algorithm, which we call A-star algorithm too, but we should not confuse it with Singapore's A-star agency. So, the A-star search algorithm is actually a modified Dijkstra algorithm. What it does is that you add an additional parameter to the Dijkstra search algorithm, where it's going to add in something called a heuristic. So this heuristic will determine which node it should traverse next. And I'm not going to go through in detail because the algorithm itself is a quite lengthy explanation, but you can look up Wikipedia. It's got a very good explanation up there. But essentially, what A-star algorithm does is that it always finds the shortest path from one point to the destination without having to traverse the entire graph. It's almost always going to be the most optimal, if not the second or the third most optimal path from one point to the second point, without having to traverse the rest of the graph. We are only going to be traversing like 1/3 or 1/4 of the entire size of the graph, only along the path where it actually leads us to the destination. And so we don't do any redundant calculations. We have no performance overhead, and therefore it is very good for games, right? We don't always require the enemy to move on the shortest path possible. As long as it gets the work done pretty efficiently, we are fine with it. And so A-star is currently the most widely used pathfinding algorithm in all game engines that you can find that has this algorithm implemented. But all this say, right, like, what, do I need to write my own algorithm in the engine? No, okay, that's a whole lot of trouble. So luckily for us, Unity has this very cool API called a NavMesh, which stands for short as the navigation mesh as in a 3D object. What it does is that it is a library or a utility that is available in the Unity engine, which implements almost all the stuff that we need for AI pathfinding. It includes things like baking the terrain, which converts your entire game stage into graph nodes, storing the data, and then allows you to do pathfinding with the A-star search algorithm. And it also provides API to move entities that are supposed to be moving on the navigation mesh. And you can also easily add and remove obstacles or navigable surface from the game scene. So, with that out of the way, let's do some hands-on. So, remember this game scene that we had from like 5 weeks ago, right? So, it's not very interesting, but it is what it is. We have a very basic terrain, we have a player, right, and everything, which is perfect for a quick demonstration. So, the way how you can integrate NavMesh into your game, the only way to do it is to, first of all, you need to open up the package manager for Unity, which can be found in the window menu. So under Unity registry, you want to search for AI navigation. It shows up here, and then you can install this package. Once you install this package, NavMesh will be available in your project. As to why they don't include it as the base package, I guess is because not everyone requires NavMesh. So once you have the NavMesh installed, you can see that I have an additional menu here, which is called AI Navigation, which comes with the NavMesh package. And here we are able to select multiple things that allows us to see what the current navigation mesh looks like. So in order to start this off, first of all, we select our terrain or our ground object, and we just add the NavMesh surface to it. Once you've done it, you can see that there are several different agent types, which usually starts with only one default, but you can add more. There's a default area where you can determine whether or not this area should be walkable, should be not walkable, or should it be like a jump surface for your AI. Then the generate links, usually not very important, and geometry, you can change the way how the NavMesh actually transforms your map into a navigation mesh. Usually you'll go with random meshes, which is going to take the physical geometry of all of your 3D objects in the scene and convert it into a nav mesh. Or you could use Physics Collider, where you can make it such that only objects with colliders will have the nav mesh, and the nav mesh is going to stick to the surface of the collider instead of to the surface of the triangles on your mesh. So depending on what kind of effect you're looking for, you can choose from either one of these. But for this purpose, I'm gonna use random mesh, and all of these not very important. Yeah. So once you have it set up, right, all you need to do is to press bake, and you can see that it bakes the mesh, and there is like a bluish kind of area around the map now. So this is the nav mesh. So this bluish area denotes the area where like an AI would be able to move. So once we have this nav mesh, we probably want some kind of thing that can move with it. So for this purpose, I am just going to give this player, let this player be its own AI, for example. And all you need to do is to add this nav mesh agent component to it. Select an agent type, which currently only has humanoid on it. And there's like the speed, the angular speed, the acceleration, stopping distance, radius, everything. You can use this to fine-tune the overall behavior of how the agent is going to move. For example, obstacle avoidance. This radius here denotes that how far away should the AI avoid the obstacle. With a radius of 0.5 units, it means it's going to try to deviate away from the obstacle for 0.5 units and then try to circle around the obstacle. You can change this value. Height as well, like how tall, like if there is an obstacle on top of it, should it go through it? Like what is the height where you should let it stop, for example. So quality is like how high quality should this avoidance be? There are multiple choices to choose with. If you choose no quality, it means it's not going to avoid anything. If you choose low quality, it means it's going to avoid like maybe 15-20% of the time, and then it scales until high quality where it's going to avoid like 99% of the time. So it'll be like, it feels like very intelligent, where it can find all the fastest path with avoiding all and then whilst avoiding all the obstacles there. Okay, where were we? Yeah. And then the distance where it's supposed to stop from its destination, the speed where it's going to take, how fast it's going to turn, how many degrees per second while following a path, what's the acceleration, how fast it should start accelerating to its max speed, etc. And then there's also auto braking, where it's going to avoid overshooting from the destination. When it reaches the destination, is it going to just stop completely, or would it walk over the destination, etc. So all of these settings are available for us. Priority is like if it was going to avoid or ignore all other agents that are calculating. The lower the priority, the lower the priority value, the more important this AI is. So it's going to try to calculate the path for a lower priority AI before it calculates a path for a higher priority AI, for example. Then the rest of this, usually you just leave it on because it's like some kind of traverse of mesh, repath when it's supposed to repath, etc. So once we have this nav mesh agent attached to something, the next thing that you need to do is to attach a script to it, of course. Like, we're using Unity, that's all the things that we should do. We should write scripts. So for this one, I'm just gonna call it like, okay, let's just call it nav mesh AI for easy, for purposes. Yeah. So once we have this script opened up. Right. It takes a while. Okay. So the first thing that you want to reference is the NavMesh agent. Hang on. The NavMesh agent component. We're gonna just call it agent. It's under the namespace of UnityEngine.ai because, of course, it's an external package that you need to install yourself. So after you have this reference, again, you need to grab the reference from the player. So after you get this reference, in update, you can use this to access all of its API. For now, we're just gonna move it to a certain location. So you just need to call agent.move, and then you just need to move it to like somewhere. Add relative movement to the current position. So you can call it like something like this. But yeah. And we also need to give this a destination, where you can set a destination here. And I don't think you need to move when you have the destination already. Okay, so the thing about baking your NavMesh is that it takes into account all of the colliders that you have, and it's gonna try to render around it as if it's obstacles, but we don't want that effect. So usually you're just gonna move the player away, and then you bake it again so that it covers all the area. Alright, now that we have that, we're gonna move this back down. Okay. And we are going to add an object, which is gonna be our destination. I'm gonna set this to like somewhere around okay, let's put it here. Alright, so we're gonna put it here, and then we're gonna reference to this here. So the transform destination, and we can just call agent set destination to destination dot position. Cool. So now as we get back, let me also just remove the character controllers and the input scripts that we had last week, and add a capsule collider to this. So everything is set up now practically, and all I need to do is to attach this script onto it and set the destination. Now as I press play, it just moves over like right away. We can see that this path here is like quite tall for it to walk over, right? So it just avoids it and then just completely goes to a completely different direction to get to the destination. And you can just put it like anywhere. It's like magic. It's actually like magic. You put it anywhere on the blue surface, you press play, it's always gonna find the shortest path to it, which is very cool. So that's it, we have it. This is how this is like 3 lines of code and then 4 seconds of setting up, and you can just have like intelligent pathfinding in your game, which is very convenient. But there are some other APIs that you can use, which you can find it on Unity's NavMesh here. So there's like a bunch of stuff that you can use here, and yeah, you can just try to find like which API you need, but this is like the basic, where you just have an AI, you set a destination. And this is very cool because all you need in update, right, is if you want your enemy to chase over the player over and over again, for example like in Minecraft where the zombie chases you, you can just update to the player's position every single frame, and it's going to try to find closest path to it every single frame. But what if there are certain surfaces that I don't want to be navigable? Like I mentioned just now, baking the nav mesh changes all the meshes or all the objects in your game scene as a navigable mesh. So let's take an example here. We're going to add a 3D plane, like somewhere here. We can add it like somewhere here. It's so far away from this original mesh. We click on this, we can see that the surface is actually attached to this ground object, and this plane is completely like different of it. But as we bake it, it actually bakes over. There are certain times that you don't want this to happen. For example, you want certain surfaces to be non-navigable by zombies or some kind of enemy, like if it's a water surface or whatsoever. You don't want this to be navigable. So what you can do is that you get over to this object that you don't want to be navigable. You have to add a NavMesh modifier. So adding this modifier allows you to change the property of this current object for the NavMesh. And the mode, we can just change it as add or modify object, and then click on override area, which is going to override the current area of this piece of mesh to whatever you want it to be. Right now it's walkable. If it changes to not walkable, oh, sorry, didn't meant to press play here. Okay, if you change this to not walkable, and as you bake the nav mesh again, it's not going to be able to walk on it anymore. As you can see, the bluish surface is gone, which means this is no longer a navigable surface for any kind of nav mesh agent. So you can play around with it, but like adding a nav mesh modifier to every single object in the game scene that you don't want to be navigable can be very time consuming. So Unity has an easy way where if you have multiple surfaces, if you have multiple surfaces that requires you to change the nav mesh properties, for example like this, like you don't want this and this to both be navigable. Let's remove this first. As you bake it, you can see that all three areas are navigable. What you can do is to create an empty object called non-navigable or anything that you like. Then you can drag these surfaces that you don't want to be navigable under it as its child object, and then you add this onto the parent object, override area, not walkable, and as you bake it, it's going to all be not walkable. So this is pretty convenient, if I say so. Yeah. So there are also other things that you can play around with. For example, there are other components that you can play around with. For example, like the NavMesh obstacle, NavMesh link, the modifier volume. I'm going to leave this to you guys to figure it out. But long story short, obstacle allows you to add obstacles that the AI should avoid from. And you would probably want to add it to things like trees, or like, I don't know, some obstacles that you have in your game that you don't want the enemies to just get stuck on it. Not fun. There's like NavMesh link, which allows you to create some sort of bridging effect between two navigable surface and a surface that is not navigable. For example, you can make a bridge between two sides of a river, and then if you add the NavMesh link component to it, you can make that walkable, and then it can walk over that part of the bridge to get to the other side of it, etc. So you can try to play around with that. I'm not going to go into too much detail. So the final thing about NavMesh is that, as you can see, like, it kind of works well, but what if I have enemies of different sizes? Like, of course you don't want a fat enemy to fit through the same size of a hole or a door that a slim enemy could. You probably want it to get stuck there, or you just want it to find a better path and walk around, right? So Unity also provides a very simple solution to this. Remember this agent type that we went over, like the first thing on the NavMesh surface? You'll be able to add new agents, you can define their names and everything. Like for example, if I call this like fat agent, okay, not offensive by the way, right? You can change the radius of this, which changes the size of the collision detection of the AI. So if I increase this radius, you can see that it gets like visually larger. I'm gonna increase this to like at least 1 times the size of what it is right now. You can also change the height. Like how tall is this agent supposed to be? You want this to kind of reflect the physical appearance and physical size of the enemy that you want this agent to be. And you can change the step height as well. Like how tall can it step? Like what is the intervals that this AI would be able to step up on top, etc. And you can change the slope, like how steep can this AI scale on top of a hill, for example, on top of a mesh. There are things like drop height and jump distance that are pretty self-explanatory, so I don't think I need to talk about that. So once you have defined this new agent type, what you can do is to go back. Let's create a new object. I'm just gonna give this another capsule, and then I'm gonna increase this size. Like let's just make this like larger. Okay, not like this. Okay, let's just make this like 2 times larger on both sides. Like this is big. Okay, this is big. Now we can add the NavMesh agent object onto this and change the agent type to fat agent. You can see that how the agent looks like what the radius of the agent is with this green outline, which kind of resembles a collider. So now we have like a small agent and a big agent. If we add the AI onto this and we set the same destination, and then you need to make sure that you bake this surface. But each surface can only be baked onto one type of agent. So you have to add a new surface, change this to the bigger agent. Okay, this conflicts, but I think it's okay. Is it? Consider decreasing max slope. Okay, let's just increase max height. There are some settings that it's gonna warn you about, because if you don't follow these kinds of like intuition value, it doesn't feel right if the agent would be able to move away or something. Okay, but anyways, we fixed that. So as you bake it, you can see that there is a second layer of bluish, and this second layer of bluish is the areas that this like fat agent will be able to move. So once we have this, if we actually give it to move to the same destination around the same starting point, you can see that it's going to take 2 different paths. And the reason why this can step over is because it's got a larger step size. Okay, I think I should probably try a different example where I add a cube somewhere. Okay, so assume that there's like a wall around here. And like add a wall around here. Okay, so I'm gonna make this like not navigable by the fat guy. Just add it to the non-navigable part, and then we bake it again. Okay, now you can see that this part is like non-navigable by the fat guy, but it's still navigable by the thin guy, like the slimmer dude. Yeah, so okay, let's bake it again and make it like a bit better. yeah, okay, so you can see this part is still there, but this part is not there anymore. So as we know that the shortest path from this part to the destination, which is here, is probably gonna go through this small gap. But because this larger guy cannot fit through this gap, we don't want this to go here. And as you can see, once we press play, it's actually gonna try to get stuck there. It's going to go to the distance where it's closest to it. And that's because this part here, it can also no longer pass through. So let's try to shrink this down a bit. Let's move this around there. Yep. And then we're gonna bake both of the thing again. So you can see that it's gonna take like two completely different paths to get over, even though it's going to the same destination. So yeah, there's like a lot of things that you can play with. This package is very, very powerful, so you can always count on it if you don't know what to do with pathfinding. But yeah, so any questions? No? Alright, so with that, this would mark the end of today's presentation. So thank you for listening, and you can work on with your games now.